Finish off our notes from last time. To start with, we're going to talk about compound interest. This equation you should have seen in a previous math class. And something new to our class is we're going to talk about this new limit, the limit of 1 plus 1 over x, all raised to the x power. And that's equal to e. I would love for you to go and put this in your calculator, put this function right here in your calculator, and look and see what the horizontal asymptote is. You'll get something like 2.71828. In other words, e out of it. So what's going to happen as we take this equation and we want to compound it an infinite number of times. Hold on just a second. All right, back again. So as we take our limit, all right, so sorry about the pauses. Not sure why I keep seeing this circle on my screen. We're going to take this limit of our function as n is approaching 1,000 or infinity. As we do, remember p here is just a constant we can pull out in front. It's only the things that involve the n that we're concerned about in the limit. Now this doesn't quite match this setup here, so we need to discover what x itself is, and for this case we can say that x is going to be the relationship of n over r, and when we do that we can write this equation as p equals the limit as n approaches infinity of 1 plus 1 over n over r, so that we can have that x term. And then so that we can be consistent, we're going to call this n over r. Now notice we do have this extra r term here, so to be legal about this, we're going to multiply everything to this r power. So these arms technically will cancel and go back to this power of n that we see here. Now we can write this in terms of our limit that we see here as the principal times the limit as n approaches infinity of 1 plus, I'm going to go ahead and call this x, 1 over x, all to the x power, all raised to the r power. And this limit right here I told you is equal to e. So we get this new equation out for when continually compounded interest of p equals e to the r. And then, of course, we'll talk about this in terms of how many years we're compounding interest, so this will change to e to the rt. So I'm going to use this equation in my next example, and I'll do that in my second video.